Okay, these are our notes for section 8.1b. We're looking at a quick review from yesterday, solving a system of linear equations using either substitution or multiplication. First one is set up, both equations are in standard form, so using that linear combination or adding multiplying method is probably the easiest. We do not have opposite variables right now, but if we multiply this first one by a 2, our x's would drop out. All right, so multiplying by 2, we get 10x minus 4y equals 8, combining with our second equation. All right, our intent was to get the x's to drop out, but you'll notice that in this case, both the x's and the y's drop out. So we have nothing left on the left side, and on the right side, we're supposed to have a 15. And since 0 does not equal 15, we say there is no solution to that system. Our second one is set up kind of for a substitution. We have a single variable here, so we can substitute in this for our x, which gives us this equation. 5 times 4y minus 8, that quantity, minus 20y equals a negative 40. Distributing, we get 20y minus 40 minus 20y equals negative 40. We have no more x's, but if we combine our y's, you'll notice they drop out, and we get the statement negative 40 equals negative 40. Since that is true, we say there are infinitely many solutions that satisfy one of our equations, and the easiest equation is that first one. So we can say that satisfy x equals 4y minus 8. Okay? So if you get a false statement like we got over here, you get no solution. If you have a true statement, you get infinitely many solutions. All right, shifting to today's topic. We are looking at setting up a system of equations to solve a few word problems. So the first thing is make sure you read through the question and that you understand it before you start trying to come up with equations. It says a company that manufactures concert shirts has a fixed cost of $300,000. Additionally, it costs $12 to produce the shirt, and the promoter gets $18 per shirt. The costs are being sold at $80. So the first question says to write a cost function, C of x, for producing x shirts. So what does it cost to make the shirts? It says here we have a fixed cost of $300,000, and then it says it costs $12 to make each shirt, plus the promoter gets $18 per shirt. So total cost for the shirts would be $30. Okay, that's your variable cost. You're going to spend $30 per shirt. So if we make 10 shirts, you just spent $300. So 30x plus we have fixed costs of $300,000. Right, that's your electricity, building rental, all the things that stay constant each month. Or relatively constant, I should say. Part B says to write a revenue function, R of x, for selling the shirts. So this is how much they are going to make, all right, by selling them. And we are told right here that we're selling them for $80. So our revenue is $80 times whatever number of shirts we sell. Now we have to look at Part C. It says to find the break-even point. Break-even means that your cost equals your revenue. In other words, you haven't made any money, but you haven't lost any money. So we're really looking for when does our function C of x equal our function R of x. Cost equals revenue. So if we do our substitutions, we've got 30x plus 300,000 is our cost equation. Our revenue equation is 80x. All right, solving, we can subtract 30x from both sides. That gives me 300,000 equals 50x, and if I divide by 50, I get 6,000. Okay, now, x stood for the number of shirts, which means in this case we have to sell 6,000, should say make and sell. Make and sell 6,000 shirts just to break even. So if we want to make a profit, we would have to sell more than that. All right, our last example says when a crew rows with a current, It travels 14 miles in 2 hours. Against the current, the crew rows 6 miles in 2 hours. Let x be the crew's rowing rate in still water, and let y be the rate of the current. All right? Find the rate of rowing in still water and the rate of the current. So they're looking for x and y. They've set up a chart for you. The big thing here is to remember that distance equals rate times time. So we're going to use that setup. If we are going with the current, all right, in other words, the current is helping push us along. We have our speed that we're rowing at, plus we get the help of the current. All right, our time is 2 hours, and our distance traveled is 14 miles. When we are fighting the current, in other words, rowing against it, now we have to subtract. We're looking at the difference between how fast we can row minus the rate of the current that's pushing us back. All right, time is still 2 hours, but now we only cover a distance of 6. All right, so we can set this up. Distance equals rate times time. Time times time times rate is distance, the same thing. So if we say we take 2 hours and our rate is x plus y, we go a distance of 14. If we spend 2 hours fighting the current, x minus y, we get a total distance of 6. So you now have a system of equations, all right? They're not quite in standard form. We would want to go ahead and distribute. So 2x plus 2y equals 14, and 2x minus 2y equals 6. Again, this is set up nicely just for a addition method. Right? If we add the two equations, 4x equals 20, which means x would have to be 5. And if you go back to what we set x up to be, it said x was the crew's rowing rate in still water. So we are going 5 miles per hour. That is our rowing speed. Okay, now to find the current speed, we need to solve for y. So we're going to plug this back in. You can plug it into either equation, it doesn't matter. All right, I'll just plug it back in here. We've got 2 times 5 plus 2 times y equals 14. 2 times 5 is 10. If we subtract that from both sides, we've got 2y equals 4, which means y is 2. In other words, the current is flowing at 2 miles per hour. Okay, so in your homework today, you're going to be looking at solving or setting up some systems from word problems and then solving those.